Hello and welcome to DSR Batch 30 presentation. I'm Madhuri and my mentors are Adam and Tristan. A big thanks to them. So today I'll be presenting my portfolio project, Sanjaya, a visual question answering bot with voice assistants. So this is the overview for my presentation and there will be a demo at the end. So let's begin. So why Sanjaya? So for this, I will tell you a story from Indian epic Mahabharata. So Sanjaya, he was an advisor to a blind king, Dhritarashtra. He had gifted power of seeing the distant vision. So that means, suppose if you are a DSR and he can see what's happening in India, for example. So what Sanjaya used to do, he used to tell what's happening in the war place to the king. So the king, Dhritarashtra, he will be asking the question, who is the powerful person, who will be winning, and all those kind of things. So he was like a question answering machine for the Dhritarashtra. So Sanjaya was the VQA bot at that time, and my Sanjaya will be the VQA bot for this time. So that is the main reason for my motivation why I want to select Sanjaya. So basically, it's a fusion of NLP and computer vision with a talking power. Yeah. So what is a VQA system? A visual question answering. This field is quite a lot of this field is in research for quite a lot of years. So it's nothing. It's just a basic, you are passing an image and you are asking the question about that image, and these input is going to an AI system and an answer is generated. So it's simple question answering. So why Sanjaya? How my model will be different from the conventional VQA? So for this, I considered the limitations from the existing research things that happen in VQA, for example, like image captioning. So a person can caption image and all those things, but there are some limitations like image captioning. It's quite generic. For example, if you see in this on my right side, there are two people who are sitting in a wheelchair and one is holding a racket, but this information doesn't depict like what color t-shirt are they wearing, what is in the background, what they are holding. So it's like it's in the course, it's a course understanding of the image. It's not the fine understanding, and it's not active. So the next game was VQA. VQA is I'm talking about a conventional VQA. So conventional VQA, a user can actively ask questions, what is in the picture and what they are wearing and all such. You can see an example on the side, right side of my screen. Yeah, but mostly these kind of VQA system returns answer in single word. Yeah, so this falls short of rich linguistic capability of human. Human can do a lot better. So why VQA with full sentence answer? So this is the main motivation. Like currently we have VQA model, but with a short answer. But my VQA that will generate a full sentence answer. So it's like more connected towards human. So human feels more connected. And with the previous VQA conventional system, it was like you feel not that connected because it's a single word answer. Here you get more interested, more motivated to go into the details of the thing. So the application, what I can think of for this VQA model, like intelligent robots. Human can speak with these kind of robots and they can narrate, and the robot can inform about the surrounding images and they can do the work. For example, in house, there can be house robots. They can do the service in the home. The owner can say, please do this, please do that, something. So that can be a question answering thing. And it can also be in the case of product discovery. And it can be very useful for visually impaired users. Already Facebook API has tagged the images. So with this information, we can develop quite a good VQA system. Yeah. And the next application I can think is like people who are not visually impaired, but they are situationally impaired. For example, people like data analysts, they have to analyze a large amount of data and they need to get information. So this kind of VQA system can be very helpful for them. They can just query and they can get the result from those visual data. I can think of like a surveillance system in that you will have a lot of terabytes of data of the video recordings. Then it's quite a big task. So the people can just ask the question about those detail and you will get an answer very fast. Yeah, and even it's quite useful for medical professionals because nowadays we know there are a lot of data available in visual way. So the doctor can confirm their finding by asking the question about the image, whether their finding is correct or not. So it can be one of the application I can think of. Apart from that, in educational industry also it's quite useful. Teachers can use this and ask kids to study or something. I mean, there can be lot of applications. That's what. Yeah, so this is my model architecture. So on the left side, you can see there is a laptop, that is the user. He will select an image and he will ask the question about that image. So for the question, whether the question is valid or not, my question validation module will have a check for that. So if the question is valid, then the valid question will be forwarded to WILT, a vision and language transformer. So after getting the valid question and the image, the WILT transformer will give an answer, girl. Who is under the umbrella? Girl. So that is the conventional VQA system. It provides answer in single word. So next, what I'm doing, I'll be forwarding this short answer string to a T5 small transformer. So the main purpose of T5 small transformer is to generate a sequence of character to make a short answer to a long answer. So the output of transformer will be like the girls is under the umbrella, but it may not be in a proper grammatically form. So for that, I introduced a T5 grammar module, and then this result will be passed to this grammar module, and then a grammatically corrected sentence will be visible to the user. So this side on the left side, you can see this is the chat part. On the right side, there is a audio bot, that is the audio integration with this functionality. So the functionality is almost same. You can see the flow. On the right side, there is a user. He's asking the question and about this image, and I used Facebook speech recognition that will convert speech to text, and this question will be passed to the question validation module, and as usual it will check for whether it's correct or not, and then if it's correct it will be passed to the WILT transformer, and then a short answer will be generated, and the flow is the same as you see. Yeah, after the grammar module it will be passed to the user in the form of audio. So for that I'm using a speech synthesizer. So next, yeah, so I will talk about the data sets. Yeah, so I tried exploring quite a lot, but I was not able to find the data relevant for my problem. So what I did, I wrote all the data by myself. So it was quite tedious task. So it took around 5-6 days for me to do this. So you can see, for example, this kind of data I needed. So we have data like question and short answer, but I needed a data where I need a question, short answer, and the long answer. So this is the data format that the T5 small generator expects. Yeah, so now I'll go each and every module in detail. So as I said, my first module was question validation module that I did myself. So this module did a validation check on the question. So for this module also, I use the same data set that I created. Only thing I duplicated, like question, because it's checking whether the question is valid or not. So if question is valid, it is 1. Or if it is not valid, it is 0. So for that, I made all answers as invalid and I provided 0. So in this way, I duplicated my data set. So from 4,500, it became 9,000. So that was quite good size. So for that, I did a text vectorization, and then in a pipeline, I fed this data, and then I passed it to the logistic regression model. So logistic regression, I found quite a good result with that. It's almost 98%. So that was quite good. So the data, the question validity, even I have to check, it was really good. All because I had a very high quality data, maybe. Yeah. So after this question validation module, now we have a valid question. So this valid question is fed to the built transformer. So this transformer, I took it from Hugging Face. It's already pre-trained, so I didn't do anything much on this. Yeah, so I fed the image and I gave the question, and this module took care of everything, and it returned an answer in 1 word. So next, once you got a short answer, the short answer is fed to the T5 small generator. For this, I did quite a lot of work. Yeah, whatever data I created, I pre-trained this completely on locally on my laptop. And then I fine-tuned on my downstream task. So my downstream task is to convert the short answer to the long answer. And this T5 is nothing but a sequence generator. Yeah, once the short answer has become long answer, then we need to check for whether it's grammatically correct or not, readable or not. So then I pre-used T5 grammar module from Hugging Face again. Yeah, and then this this grammar module has given me a quite good result, and you can see. And now I have a full sentence answer for a question that I asked about an image, and that also in a very good grammatically correct form. Yeah, and for speech interaction, text to speech and speech to text, as I said, I used WebKit speech recognition for speech to text and WebKit speech synthesizer for text to speech. These two libraries are provided from Python by JavaScript for integration to Streamlit. Yeah, so this is the output. You can see, like, after Wilt, I got an answer. I asked how many cars are there. It returned 0. So it's a 1-word answer. Next. This is T5, small, pre-trained, and fine-tuned, but not grammatically correct. Now the same question became, there is no cars. So now I fed this to the grammar module, and now you can see the result. It's proper. There are no cars. So this is grammatically correct, right? For deployment, I used spaces from Hugging Face. As front end, I used Streamlit, and the backend binaries, T5 and question validation pickle, I deployed at Hugging Face too. So this is my model name, T5 small VQA-FS. You all can find it online. Yeah. And now I will show the chat bot demo. And for AudioBot demo, because of technical glitch, I have recorded the clip. So once I finish chatbot demo, I will go ahead with audio clip. So this is my application at Hugging Faces. So I provided an option of chatbot and AudioBot. So first, I will demonstrate how this chatbot works. So you can see the results are quite convincing. Where is the cat sitting? The cat is sitting on the couch. What color is the couch? Yeah, the couch is brown. So if I give something that is not a question, let's see what happens. So it returns, I can understand only questions. Can you please ask a valid question?
Man is in the picture.
What is he doing?
He is using a laptop.
What is in the background?
The fireplace is in the background.
Is the fire on?
The fire is on.
Yeah, now about the results. For the question validation module, as I explained, I got already a 98% accuracy. So yeah, it's quite good. Next, for the T5 module. So for the T5 baseline module, you can see the figures. So my model performs quite better than the baseline model here in front. Yeah, so for conclusion, yeah, I presented a visual QA model with full sentence answers, and it can talk too. And I created a data set, quite a big one. Yeah, so current limitations are like it doesn't understand the semantic meaning. I need to provide more data for more scenarios, more kind of questions to be covered. And the performance is little down because I had two T5 module. So what I could have done, I could have used single T5. In that I could have made the thing. So then there will be only 3 models instead of 4 models. And yeah, because of the speech recognition WebKit, it runs better in Chrome browser. Yeah, and the large model like GPT-3, they are quite costly to train and deploy. So in future, I want to train more on the GPT-3, GPT-J kind of model to see how it performs, whether it performs better than my fine-tuned model or not. I want to have a check for that. And in future, I want to support multilinguality, like I can have a lot of languages, French, Spanish, and so on. Yeah, and better user interface so that it will be more good and feel. Yeah, so currently I use Wilt from Hugging Face, but in future I want to train myself on big image data set and to see and explore more about how it performs. Yeah, as you have seen, I haven't done the real-time audio integration, but this is in my plan. And also visual question answering for videos. You can connect me at this link. The project, the VQA project is deployed in Hugging Face, and the complete source code you can find at GitHub repository. Thank you.